before you have studied in calculus 1 the continuity of the function. So in 5.5 we shall discuss indefinite integral. So what is indefinite integrals? If we have integrals without limits, without endpoints, okay, this is indefinite integral. And how can we solve this indefinite integral? By substitution method. So we shall discuss in 5.5 indefinite integrals and substitution method. Mean we shall put something and convert the complicated integrals into simple integral and then solve after, and then again convert back to our substitution. So in 5.6 we shall discuss the substitution method for the definite integrals. It means previously we have discussed indefinite integrals and substitution method in 5.5. Now in 5.6 we shall discuss definite integrals and substitution method. It means we will solve definite integrals but by the substitution method, and we will find the area under the curve. So this is chapter 5. So after it chapter 6, but chapter 6 is little bit tough, so we shall discuss at the end. Okay, so after chapter 5 we shall discuss chapter 7. So in chapter 7 we have just two topics. So one is hyperbolic function and the second is L'Hopital rule. So in hyperbolic functions we have just two things, just two things. One is hyperbolic functions, means sine hyperbolic, cosine hyperbolic. So these are two fundamental hyperbolic functions. The remaining four, it means tan hyperbolic, cotine hyperbolic, sec hyperbolic, and cosec hyperbolics can be derived from the sine hyperbolic and cosine hyperbolic. After that, we shall discuss the properties of hyperbolic functions. After it, we shall discuss the derivative, like calculus 1. Uh, what is derivative of sine x? So in hyperbolic function, we shall discuss what is derivative of the sine hyperbolic x, and what is the derivative of cosine hyperbolic x, what is derivative of tan hyperbolic, what is derivative of cotine hyperbolic. So all the derivatives we shall discuss in hyperbolic function. After that, uh, we will study inverse hyperbolic functions. Then at the end we shall discuss derivatives of the inverse hyperbolic functions. So after that, in 7.5 we shall discuss L'Hopital rule. So what is L'Hopital rule? We will have a function, rational function. It means function divided by functions. It means quotient form, quotient function, function divided by function. And we have to find the limit if we have three things. It means 0 over 0, infinity over infinity, minus infinity over minus infinity. Then we will use the L'Hopital rule. And as application of the L'Hopital rule, we shall solve intermediate form. What are intermediate form? It means if we have function, Zaraf function, and one function has the limit 0 and other function has limit infinity, or the first function has limit infinity and the second function has limit 0. So one is this intermediate form. The second is we shall discuss if we have function power function and we get the limit of f of x 1 and the limit of g of x infinity. It means 1 power infinity, 0 power 0, infinity power 0. So for this case we will have 6 different steps to solve this intermediate form. uh, After chapter 7 uh, we shall discuss. Doctor, can you talk? Okay, no problem. In chapter 8, this is the main tafazul takamul. Okay, if someone asks what is tafazul takamul, you can ask chapter 8. It means the basic of the integration, basic of the integrals. Okay, So in 8.1, we have some fundamental or basic formulas of integration. That means how can we find the integration, how can we evaluate the integral. In 8.2, we will have integration by parts. So integration by parts, it means we will have two functions. We categorize these two functions as the first function and the second function, and we will use integration by parts. Suppose one function is polynomial function and the second function is trigonometric function. So to solve this, we will categorize that this function is first, this is second, and we will have some certain formulas to solve this. So also if we have exponential function and trigonometric function, then by different formulas we will evaluate and solve these by the method of integration by parts in 8.2. So in 8.3, we will have trigonometric integrals. So it is clear from this concept trigonometric. It means we have sine and cosine, tan and sec, and cotan and cosec. So there are three different types, and they will have different powers. It means suppose sine power 7, there are cosine power 6. So how can we take their antiderivatives? How can we find their integrals? So for this uh, we will have different methods using. It means basically three steps. In one we have three combination. It means one is sine and cosine, the second is tan and sec, and the third is cotine and cosec. So and their product. Okay, it means product of power of sine and cosine, product of sine and cosines, and tan and sec, and cotine and cosec. So in 8.3 we will solve trigonometric integrals. In 8.4 we have trigonometric substitution. In 8.4 we have integral, and inside integral we have square root, a jazar. So in square root we have three different expression. It means a square minus x square, a square plus x square, and a x square minus a square. Three different expressions, and we will use three different substitution. It means if we have a square minus x square, then we will substitute x is equal to a sine theta, and if we have a square plus x square, we will use x is equal to a tan theta, and if we have x square minus a square, then we will use x is equal to a sec theta. So this is trigonometric substitution, which we will solve in exercise 8.4. After that, we have integration by partial fraction. Integration by partial fraction mean we have rational function. Rational function mean function divided by function, and the degree of the denominator will always be greater than the degree of the numerator. And we will have the four different combinations. It means in the denominator we have linear, and square of the linear, and quadratic, and square of the quadratic. So in 8.5 we will solve these four different types of the questions. In 8.6 we shall solve integral tables and computer algebra system. In 8.6 we shall solve improper integrals. So improper integral is basically one endpoint is some constant, and the other endpoint is infinity or minus infinity. To solve this, we will this type of the integral is called improper integral, and also sometimes both are some finite numbers. It means a to b. So these are improper integrals. So infinite limit of integrations and integrand with vertical asymptotes. So these things we shall discuss in 8.8. So lastly in chapter 8, this is the last chapter we shall discuss in this semester. 8 sorry chapter 6. Chapter 6, we have basically the volume by using two different methods, by using cross section method and by using cylindrical shells. So we will, it means by these two cross sections and cylindrical, we shall find out the volume of some surface. And 6.3, we shall solve arc length. So there will be two different formulas with respect to x. It means arc length with respect to x and with respect to y. And at the end, 6.4, we shall solve area of surface of revolution by using it means there will be small modification in arc length, and we shall find out the area of surface of revolution. So this is the syllabus for calculus 2. This is the syllabus for calculus 2. So before corona, it was uh, the grading of uh, the grading of marks was the following. It means 25 marks was the first exam, 25 marks were the second exam, 40 marks for the final, and 10 marks was quizzes and assignments and teacher hand. It means like this. So these was the total 100 marks. But after corona, it means in the last semester, uh, we have made the distribution different. It means uh, there will be more than one quizzes and there will be some homeworks. But the student should know there are almost 15 different sections for this calculus 2. There are almost 15 different sections in the male uh, side, and same for the female side. So almost 30 sections for the calculus 2, almost. So and I am the coordinator for this subject. It means I shall make the exam for all the sections. Okay, uh, for all the section, but I shall discuss with all the colleagues. It means how many quizzes should be uh, for this subject, how many homeworks. So we shall discuss, and in the next week I shall provide you all the details, that how many homeworks, how many quizzes, and how many exam. Okay, so all these things will be in this semester. Okay, if the exam will be on blackboard, if it is the exam will be in university, so then the following procedure, then it means if the exam will be in the university, then 25 marks for the first exam, 25 marks for the second, and 40 marks for the final, and 10 marks your quizzes and assignments. But I shall convey you in the next class that what is the pattern next week, sorry, next week. Okay, if you have any question, you can ask me, then we start our today lecture. This is the syllabus for this course. Okay, students, if you have any question, you can ask. So now we start. So before starting, I have some questions for the student because you have studied before calculus 1. So what is derivative of x square? Can anyone, students, because you have studied before derivatives. So in this subject, which I shall discuss anti-derivatives. So what is the derivative of x square? X tarbiyah. What is derivative of x tarbiyah? Derivative of x square. Is there any student? Yes, 2x. Okay. So yes, it is 2x. And also, what is the derivative of sin x? Sin x, cosine x. Not negative, it is positive. Positive cosine x. Positive cosine x. Okay. So by this way, it is very easy. Like this. Now, same. If you see, derivative of x square is 2x. So what is antiderivative of 2x? Because antiderivative is opposite of this. Okay, no, not 2. I listen. Derivative of x square is 2x. Okay, this is derivative. Now antiderivative of 2x is opposite, it means x square. Yes, x square. Ahmad Saleh, it is x square, opposite of this. Similarly, derivative of sin x is cosine x. Yes, derivative of sin x is cosine x. Now what is antiderivative of cosine x? What is antiderivative of cosine x? Sin x. Yes. What is antiderivative of cosine x is sin x. And similarly, what is derivative of tan x? Sec tarbiyah. Derivative of tan x is sec tarbiyah. What is antiderivative of sec tarbiyah? Tan x. So now here the same things is given here in the definition, first definition. So here you can see a function f capital. A function f capital is an antiderivative of small f. Okay, so I denote capital for the antiderivative and f for any function. So a function f is an antiderivative of f on an interval I if. So here there is a small mistake in the book. So here we have capital F, not small. Okay, so this if the following satisfy, it means if f dash of x. Okay, you can enlarge Sultan. Here click on double click on the book and you can enlarge the picture, no problem. Okay, every student can enlarge the picture. Okay, so here it means f dash f capital of x dash, it means derivative of this is equal to small f of x. If this condition satisfy, if this condition satisfy, then f capital is called the antiderivative of the function f. I again repeat, as we have discussed by the example. So a function f is an antiderivative of f on an interval I if the following condition satisfy. What is this condition? F capital of x dash is dash mean derivative of f capital of x is equal to small f of x for all x in I. So this is basically. So here, if I ask you this small f, so small f of x is equal to 2x. Small f of x is equal to 2x. small f of x is equal to 2x. Now what is capital F of x? What is antiderivative of 2x? Small f of x is equal to 2. Now what is antiderivative of 2x? I again repeat, what is antiderivative of 2x? X square. Yes. So the answer will be equal to f capital of x is equal to x square. This is just our answer. F capital of x is equal to x square. This answer. Okay, this is answer. Similarly, if small f of x, if small f of x is equal to cosine x, small f of x is equal to cosine x. So here cosine x, what is capital F of x? What is capital F of x? Sin x. Yes, capital F of x is equal to sin x. This is the answer. It is very simple. It means antiderivative is from the derivative we can find. Okay, from the derivative we can find sin x. Okay, so this is basically definition. Now we move to the example. These examples are given here. If you see example number 1, find an antiderivative for each of the following. So already we have solved the following example, this example already we have discussed. Now we move to this. Now derivative of tan x is sec square x, sec bx. Okay, so now we find h of x, h capital of x. H capital of x is equal to tan x. Why tan x? Because if we take derivative of tan x, we have sec bx, we have sec square x plus x jazar, because x square root x. What is the value of the square root? Can anyone? What is the value of the square root? Ahmad Wassam, I asked you before. I cannot record this, so I shall to uh, try to record. I shall get some information from the IT department. Then I shall try to record. But I again repeat, if you have any question, you can send me the. I shall give you the email also. You can ask me the question, no problem. So always welcome from my side, no problem, anytime. Yes, 1 divide what on the root? Yes. So usually uh, square root, it is equal to 1 divided by 2. 1 divided by 2. Okay, it means x square root. It means? What does it mean? X power 1 over 2. X power 1 over 2. So if we take derivative of x power 1 over 2, so according to rule, 1 over 2 on the side, and we decrease 1 in the power. So 1 over 2 minus 1, so it will be the following. I shall get the following. It means 1 over 2 x square root. X square root. Okay, this thing. So this basically, I again repeat, antiderivative is from the derivative concept, because here we know that the derivative of x square is 2x. So antiderivative of 2x, x square. Okay, here if you see, the answer is given here, you can see here. So derivative of x square is 2x. uh, Derivative of cosine x, sin x, sorry, uh, derivative of x square 2x. So antiderivative of 2x, this x square. Antiderivative of 2x is x square. Antiderivative of cosine x is sin x. So antiderivative of 6 square plus 1 over 2x jazar, it is equal to tan x, tan plus x square root. So here we have some, I have some question. I little bit change. So here if I ask you for the derivative, we use d over dx. This thing. Okay. So if I ask you derivative of x square, what is this? Derivative of x square is, okay, yes, 2x. Now this, yes, 2x. So here this same, d over dx same. So if I put here x square plus 1, if I put plus 1, what will be its derivative? Yes, 2x, no change, the same, the same. So here if I, the same, d over dx, if I put here x square plus 100, suppose, what will be its derivative? Yes, 2x, no change. So here we have confusion that if derivative of x square is 2x, yes, 2x, and derivative of x square plus 1 is 2x, derivative of x square plus 100 is 2x. Similarly, if we put negative, it means x square minus 100, it will be same. So if one student can ask, then teacher, what is antiderivative of 2x? Is this x square? Is this x square plus 1? Is this x square plus 100? Because according to the rule of antiderivative, what is this? So we have confusion. You understand my point? To resolve this confusion, we have this definition. If you see, we have the following definition. It means this says that whenever we take antiderivatives, we add some constant. This constant can be zero, because here, if you see, uh, if if I ask what is antiderivative of 2x, so you will put x square plus constant, and for this case, constant is equal to 0. For the first case, constant is equal to 0. What is antiderivative of 2x for this case? You can ask x square plus c. C is equal to 1 for this case. And for the last case, antiderivative of 2x, it is x square plus c, and c is 100 for the third case. Okay? Yes, plus. So whenever we take antiderivatives, we must add some constant. We must add some constant. Okay? So here I gave you the following theorem. This is definition like this. So if f is an antiderivative of f, if f is an antiderivative of f on interval I, then the most general, antiderivative of f on I is f of x plus c. F of x plus c. So what is C? C is any arbitrary number. So like this, the previous C, in the first case, C is equal to 0. In the second case, C is equal to 1. In the third case, C is equal to 100. In the example which I gave you, C is equal to 100 in the third case. So C can be different values. C can be negative, C can be positive. You got my point? So whenever we take antiderivative, we will must add some constant, and this is arbitrary constant. This constant can be 0, this constant can be negative, this constant can be positive. Okay, so for the antiderivative, we must will add some constant. We must will add some constant. It is the necessary to add some constant. I again revise this. So if f is an antiderivative of f on an interval I, then the most general antiderivative of f on I is f capital of x plus some constant where c is an arbitrary constant. Now here one student can ask, teacher, how can we find this constant? How can we find this constant? For this case, some certain condition will also be given, like this in example 2. Here here, what is the question? Find an antiderivative of 3x square that satisfy. Now if you see, this condition is on antiderivatives because this is f capital of 1 is equal to minus 1. So here, what is now? What is this function is derivative of what? If you see, this function is derivative of which function? What function? 3x square is derivative of which function? 3x square is derivative of x power 3, because if we take derivative of x power 3, so we will get this function. It means antiderivative capital F of x is this x power 3 plus some constant, x power 3 plus some constant. You got my point? So what is the question? Find an antiderivative of this, antiderivative of this. So we got this. It means f capital uh, of x is equal to x power 3 plus some constant. Now we want to find, yes, x power 3. So it will be x power 3 but plus some constant. Okay, like this the main definition plus some constant. Now we want to find the value of the constant, the value of this constant by using this condition. It means if this condition is not given, okay, if this condition is not given, so leave, this is your answer, this is your answer, no need to find the constant. Okay, if this condition is given, it means it can be different value, different condition. Suppose it can be f of 0 is equal to some value, f of 2 is equal to some other value. Okay, so this condition will be different for each question. So first we solve this, then I put different value, so then we will solve again. Okay, so here, so the antiderivative is this. It means f of x is equal to x power 3 plus constant, x power 3 plus constant. So uh, now we want to find the value of the constant. So I use here this value. So where is x? I put 1. Where is x? I put 1. So whenever, here, where is x? I put 1. So I get the following. Here f of x, so f of 1 is equal to 1 power 3 plus some constant c. Okay, so 1 power 3 is how much? 1 power 3 1, 1 power 3 1 plus c. So we get this 1 plus c. Now here if you see, f of 1 is equal to minus 1, so I put here minus 1. Okay, then I shift this 1 on this side. This is positive, this is positive 1. When I shift on to the other side, this on this side it is positive. When I shift on the other side, it will become negative, it will become negative. Yeah, yes. So minus 1 already mojud, minus 1 plus minus 1. So minus 1 how much? Minus 1 how much? Minus 2. Yes, minus 2. So the value of c is, we got minus 2, minus 2. So if you see, the value of c is equal to minus 2, the value of the c is equal to minus 2. So then we put this value here, we put this value here. So what is the value of the c? C is equal to minus 2. Now I put here So our answer is f of x is equal to x power 3 minus 2. f of x f of x is equal to x power 3 minus 2. Now a little bit change. Now here on the place of this, if I put here f of 1, suppose f of 1 is equal to 2. Now what will be the value of the c? Here this will be the same. Yes, this is equal to 1. Why it is 1? Now we check. So first, this is true because f of x is equal to x power 3. So then here, this will become, this is equal to 2. So whenever we shift 1 on this side, so 2 minus 1, 1. Ahmad Wasam, Ahmad Salim, yes, it is. So 2 minus 1, 2 minus 1, 1. So the value of c will becomes, the value of the c will becomes 1. So the answer, what will be the answer? What will be the answer? f of x is equal to, f of x is equal to x power, f of x is equal to x power 3 plus 1. So this will become f of x, f of x is equal to x power 3 plus 1. Yes, this correct. Okay, now I change little bit. Now I change the question and give you now 5 minutes to solve this. Now on the place of this, if I give you here f of x, here it is equal to cosine x. Already you have solved cosine x. Okay, and here and change this f of pi by 2, f of pi by 2 is equal to 2. Solve this. You have 5 minutes. Solve this. Okay. Find f capital of f. You have 5 minutes. So I am waiting 5 minutes. uh, cosine x. No, little small change. Yes, I'll measure. Yes, you are correct, but uh, no. Okay, solve again. Almost here. Sine x. Sorry, cosine x. Cosine x. Sorry, it is not cosine. It is sine because what it is here. Check again. This cosine x. Okay, antiderivative is sine x. Okay, so what this will becomes? This will becomes sine x plus c. Sine x plus c. Now here, now I use this condition here. So f of pi by 2, it is equal to 2. No, Al measure was correct, but somehow. So the value of c is 1. The value of c is 1. So what will be the answer? Because why it is 1? Because sine pi by 2. Sine pi by 2, 1. So this will becomes yes. So we have 2 is equal to 1 plus c. So what will be c? Yes, 2 is equal to 1 plus c. So c is equal to 1. So what will be our final answer? What will be our final answer? So f capital of x is equal to sine x plus 1. This will be our final answer. This will be our final answer. You got my point? Okay. The antiderivative of cosine x is sine x plus some constant. So whenever we use f of pi by 2, so sine pi by 2, it is equal to 1. So we will get 2 is equal to 1 plus c. So whenever we shift 1 on other side, so this will become c is equal to 1. So if c is equal to 1, so we will get sine, we will get sine of x plus 1. Sine of x plus 1. So this will be our answer. Okay, you got my point? Understand? Students, did you understand? Yes. Okay. Now we move to, okay, Sultan. Again. Okay, I again repeat. No problem, no problem. So, no problem. I again repeat. So for the antiderivatives, we will add some constant. So this, if you see, this f capital of x, this is antiderivative of the given function, this small f. Like here, now here, if you see this small f of x, now this function is derivative of what? It is a derivative of x power 3. So if derivative of x power 3 is 3x square, what is antiderivative of 3x square? X power 3. Okay, if you see, plus some constant, same like this. If you see, so we add some constant. This is basically definition. So uh, for the antiderivative, we must will add some constant. So the antiderivative of 3x square, it is x power 3. Similarly, what is antiderivative of cosine x? Sine x plus some constant. Okay. So if I ask you what is antiderivative of sine x, it is minus cosine x. Okay. So here we see the following example. So antiderivative of 3x square, it is x power 3. Why it is x power 3? Because we have discussed previously in the previous definition, if we take the derivative of this x power 3, we get this 3x square. So if we take f dash of x, we get f of x. We get f of x. Now to find the value of the constant c, we use the given condition. So if this condition is not given, if this condition is not given, this is your answer. No need to solve more. This is your answer. This is your answer. If this condition is given, this type of the condition is given, then you have to find the value of the constant. Now here, if we have f of 1, then where is x? You will put 1. If it is f of 0, where is x? You will put 0. If it is f of 100, so where is x? You will put 100. So if it is x f of pi by 2, so you will put pi by 2. Anything. Okay. So here, as it is given f of 1, so whenever I put f of 1, so I get the following. F of 1 is equal to 1 power 3 plus some constant. F of 1 is equal to 1 power 3 plus some constant. So now f of 1 is equal to here minus 1. So c will becomes minus 2. C will become, because whenever we shift 1 on other side, so minus 1 is equal to c. So c is equal to minus 2. C is equal to minus 2. If c is equal to minus 2, then we put this value here. C is equal to minus 2. So x power 3 minus 2. X power 3 minus 2. So this is our answer. It means f of x is equal to x power 3 minus 2. The value of the constant. Okay. Now you understand? Ahmad Salim and Sultan. Did you understand? Okay. Very good. Okay. Should we move to next? Okay. Should we move to next? Okay. So the next is we have this thing, the table for the antiderivative. It means antiderivative formula. So here I asked you first, if we have d over dx of x power n, derivative of x power n. So first, what is derivative of x power n? Can anyone give the answer of this? If what is derivative of x power n? Yes, Raed Al-Mezal, correct. N x power n minus 1. Yes, it is correct. No, Ahmad Salim, n. First, you should put n. N, yes, n x power n minus 1. So how can we find this? Because first we shift the power into the zarab. It means decrease on the top. We take the power and zarab. So n x, then decrease 1 in the power. So as we have, it is antiderivative. So for the antiderivatives, okay, so if you see, we decrease in the derivative, here we put here n. It means take power and put in the zarab, and then decrease 1 in the power. So as we have to take, what is opposite of the zarab? Opposite of the zarab. What is opposite of the product? It is division. So what is opposite of decrease? It is increase. So if I have to take antiderivatives, so for antiderivative I use this. So here I decrease, for antiderivative I increase. So you have to put n plus 1. Yes, n plus 1. We increase 1. Yes. So in derivative we decrease 1, subtract 1. So in here, in antiderivative, we first of all we increase 1 in the power, then divide the whole power. Not, it means the new power, divide the whole power. So this is basically Kanun. If we have x, so x power, if I want to take antiderivative of x, so what is the power of x? It is equal to 1. It is equal to 1. So x power 1 plus 1, it will become x power 2. X power 2 divided by 2. So if we have x power 3, x power 3, so this will becomes x power 3 plus 1, 4 divided by 4. X power 4 divided by 4. If we have x power n, so x power n plus 1 divided by n plus 1. You understand my point? You got my point? Yes. So now I give you here some example. If I have x power 5, what is antiderivative of this? What is antiderivative of this? Increase 1 in the power, divide the whole power. Increase 1 in the power, divide the whole power. So what this will becomes? X power 6 6 plus C. This is answer. X power 6 divided by 6 plus some constant. You got my point? So this will becomes x power 6 divided by 6 plus some constant. This thing plus some constant. Okay. If I ask you what is now here x power minus 6 or minus 2, what is its antiderivative? What is its antiderivative? X power minus 2. So we increase 1 in the power, divide the whole power. So what this will becomes? X power minus 1, because minus 2 plus 1 minus 1 divided by minus 1 plus some constant. Plus some constant. Yes. Plus some constant. Yes, Abdullah and Raf, you are correct. So this is basically, if we have, so now I ask you, if we have x power 100, suppose, now give me the answer of this antiderivative of x power 100. Yes, Abdullah, Asmari and Raif Al-Meza and Ahmad Muhammad Aziz. X power 101 divided by, yes, this is correct. This is correct. So we increase 1 in the power, divide the whole power. We increase 1 in the power, divide the whole power, plus some constant. Okay, Osama, plus some constant. Yes, plus some constant. Okay, now this is the first formula. The second, if we have sine kx, k is any number, that means k can be 2, k can be 3, k can be 100. So what is this? Sine kx minus cosine kx divided by 2. Suppose if we have sine 2x, okay, sine 2x. So what will be the answer? Antiderivative of this, minus cosine 2x divided by 2 plus some constant. Okay, so sine 2x, what is antiderivative of sine 2x? Cosine 2x divided by 2 plus, sorry, minus cosine 2x divided by 2 plus some constant. Now I give you a question. What is antiderivative of sine 5x? Sine 5x. Yes. Student, what is antiderivative of sine 5x? By using the second formula, this. By using this formula, minus cosine 5x divided by 5 plus some cos. Yes, this is correct. This is correct. Minus cosine 5x divided by 5 plus some constant. This is correct. Okay. So similarly, if I give you here this thing, yes, Ahmad Muhammad Aziz, yes, it is correct. Minus cosine 5x divided by 5. So if I ask you cosine 5x, here, cosine 5x. So here, what is the kanun? Sine 5x divided by 5. Sine 5x divided by 5. Okay. So what will this will become? Antiderivative of cosine 5x divided by, what is antiderivative of cosine 5x? Yes, sine 5x divided by 5 plus some constant. Yes, all are correct. So these are different formulas. Okay. Now here you can see sec square kx, tan kx divided by k plus some constant, cosec square kx, cotan kx divided by 5 plus some constant, minus cotan kx divided by 5 plus some constant, sec kx. So here it is given, yes, minus cotan. So sec kx tan kx, so 1 over k sec kx plus some constant, cosec kx cotan kx minus 1 over 4 cosec kx plus some constant. Okay, so these are formulas regarding the antiderivative. Now uh, antiderivatives of, here you can see, if I ask you what is derivative of e power x, e power x, derivative of e power x, it is same, e power x. Yes, e power x. So what is antiderivative of e power x? What is the antiderivative of e power x? Yes, e power x plus some constant, e power x plus some constant. Okay, so e power x plus some constant, plus some constant, same. Okay, so if I ask you what is derivative of, now what is derivative of ln x? What is derivative of ln x? Ln x, it is equal to 1 over x. Yes, 1 over x. So yes, correct. So what is now antiderivative of 1 over x? What is antiderivative of 1 over x? Yes, my question is now what is antiderivative? No, no, no. Yes, Ahmad Salem, you are correct. So antiderivative, yes, Raed Abdullah is correct. So antiderivative of 1 over x is ln x plus c. Ln x plus c. Okay. So from the concept of derivative, we can find the antiderivative. So from the concept of derivative, we can find the antiderivatives. We can find the antiderivatives. Okay. From the concept of the derivative, we can find the antiderivative. Now we move to the some example here. If you see, by the first rule, here by this rule, so what is by this kanun, x power n, we increase 1 in the power, divide the whole power. So what is the first example? Here we increase 1 in the power, divide the whole power. So what is antiderivative of x power 5? What is antiderivative of x power 5? No, not ishtaqaq. Here, brother, not ishtaqaq. Yes, Abdullah Al Asmi. Yes, x power 6 Allah 6. And Ahmad Salem Al Arsi. Correct. X power 6 Allah 6. X power 6 Allah 6. Now for the second question, antiderivative of second, it is 1 over square root x. So square root x is equal to what? Square root x is equal to 1 power 2. So I can write in this way. This is equal to x power minus 1 over 2. Now what is the answer? G of x is equal to x power 1 over 2. G of x is equal to x power 1 over minus 1 over 2. So we add 1 in the power, divide. No, minus half plus 1. How much? Minus half plus 1. Yes. So divided by the same. It means divided by 1 over 2. So it will become x power 1 over 2, x power 1 over 2 divided by 1 over 2. So if you see, yes, x power 1 over 2 divided here, you can see this thing. So x power 1 over 2 divided by, you can see here, this thing, x power 1 over 2 divided by 1 over 2. So plus constant. So this divided by 1 over 2, it will shift to 2 over 1. So this will becomes 2 x power 1 over 2. It means x dozer plus some constant. Plus some constant. So now we move to the next. So sine 2x already we have solved by the given formula. What is this kanun? Here, this. So sine kx minus cosine kx divided by k. So here, if we use this formula here, so that is why here h of x sine 2x, it means minus cosine 2x divided by 2, minus cosine 2x divided by 2, minus cosine 2x divided by 2. Okay, you got my point, student? Yes, 2x divided by 2. Yes, he is correct. Ahmad Salem is correct. Osama, minus cosine 2x divided by 2, divided by 2 plus constant. Okay, Osama Naif. So minus cosine 2x divided by 2. Yes, Ahmad Salem, you are correct. And Sultan, you are also correct. And Abdullah Al Asmi, correct. So this, so if I solve the fourth question, same like, so cosine k x over 2, it means sine x over 2 divided by k. What is k here? 1 over 2. So this will becomes 2 x 2 sine x over 2 plus some constant, because k is equal to here 1 over 2. So this is the some example regarding the this table of antiderivative. Now we have a small uh, concept of linearity rules, antiderivative linearity rules. It means if we have any function, if we have any function, uh, it is product with a constant. K is any constant, and a small f of x is any function. Whenever we have to take the antiderivative, constant goes outside antiderivative of the function. Same like the derivative, because if we take 2x derivative of 2x, so 2 goes outside derivative of x 1, so that is why we get 2. So same like, so constant multiple rule. What is constant multiple rule? If constant is multiplied with the, if constant is multiplied with the function, so and we have to take the antiderivatives, so we have to take just, we take the antiderivative of the function. And if we have the addition of the two function, and we have to take the antiderivative of their antiderivative of their sum or the difference, then uh, we take the antiderivative of the first function plus antiderivative of the second function. Okay, so now here if you see, we have the following example. F of x is equal to 3 divided by x jazar. So x jazar, x square root, we shift on to the numerator. So this will becomes 3 zarab x power minus 1 over 2 plus sine 2x plus sine 2x. So what will be the antiderivative of uh, x power minus 1 over 2? It is equal to 1 over 2. So that is why 3x power 1 over 2 divided by 1 over 2. So this will become 6x power 1 over 2. It means x jazar minus what is antiderivative of sine 2x? It is equal to cosine 2x divided by 2. So this is our today lecture. This is our today lecture. In next class, uh, in next class we shall discuss if we have more than one, uh, if we have a function in terms of the derivatives, how can we find the antiderivative? It means like we have four times derivative, how can we get the original function? How can we get the original function? So one student gave me the email ID such that I can send you the book and the syllabus. Okay, give me your one student, and you can make some WhatsApp group. You one student which is active, he should make some WhatsApp group sometimes, and who is punctual also, who is punctual also, because in the future I shall give to him. Okay, if you have a group, very good. If you have a group, very good. So, uh, okay, you give me your email ID. No, here actually I have put here. So I am sending here this Raed to Raed Al Mezan. Okay, you can get from him. Doctor, what about attendance? So just wait. I shall take here screenshot of your attendance. Okay, and it will directly goes to the system. So just wait. First I am sending you the book and the syllabus, then I shall see the, just wait, just wait. So I sent to Mr. Raid. Okay, so you can get the book from Raid. I have sent to him. Okay, and I shall ask to Mr. Raid Al Mesal, please give to all your colleagues such that they do not need to purchase the book. Okay. Yes, about the attendance. Okay, 1 minute. I make the attendance. Okay, I just am making the attendance. Uh, 2 days, 31. Okay. So if you have any question, you can ask. If you have any question, you can ask. No problem. Okay, about the syllabus for the first exam. So some student ask this question: uh, what will be the syllabus for the first exam? Uh, in the first exam, in the next week, I shall give you the syllabus of the each exam. It means how much the syllabus for the first exam, how much the syllabus for the second exam. So I shall provide you all the details regarding each exam. Okay, and one thing more, uh, if the exam will be on uh, uh, blackboard, so before 15 days I shall give you that the exam will be on this date, and I shall try to give more time. It means such that all the students can get good marks. Okay, which will be the rule of the university, not by myself, but I shall try to convince the chairman that uh, okay, exam will be subjective or objective. It will be objective, because uh, if it is on blackboard, it will be objective, because how can we evaluate uh, your expertise? It means if it is subjective, then how can we check this? Okay, it will be objective, inshallah. So uh, and in objective, now it can be a question. In objective, there will be mcqs or fill in the blanks are true and false. So there will be usually uh, mcqs, multiple choice, and true and false. So there will not be fill in the blanks. Okay, so there will be two types of the question. One is mcqs, multiple choice, and the second is true and false. So if you have any question, you can ask. I again repeat, any student have any question, please ask. I shall always be available, inshallah. Okay, I always available. Okay, most welcome to all the students. Okay, see you in the next class. Thank you so much. Thank you so much. So see you in the next class. Thank you so much. Bye.